Okay, welcome back, everybody. Here today, we are going to learn about more quadratics, but we're going to learn about quadratic functions today. So here are the notes. Quadratic functions 2.3. Okay, and yes, on the left side, just like these are our OneNotes, you can download the Word file and download the PDF as well. Okay, so let's get started. Okay, actually, increase that screen. There we go. Okay, so a quadratic function is a second-degree polynomial, means the highest degree is 2, or the largest exponent is 2. The standard form of a quadratic is f of x equals ax squared plus bx plus c. That is the standard form of a quadratic function, and that is the form we will be working with today. And for it to be a quadratic function, the leading coefficient a can never be 0. So you see that. Okay, so some characteristics of the graph of a parabola, which are the two pictures down below. Oops. All right. So if our parabola opens up, first thing to notice is that down here, the leading coefficient is greater than 0, which means the leading coefficient is positive. Which means if you have a positive leading coefficient, the parabola opens up. Okay, and now if our parabola opens up, there are some things that you'll see. First off, the main point of the parabola is the vertex. So that is right here. That's the vertex. You will always have a vertex, okay? Okay, and then you will definitely always have a y-intercept. You will always cross the y-axis. So you'll always have a y-intercept. And now, x-intercepts. So depending on our quadratic function, we may have 2 x-intercepts. You may only have 1 x-intercept, or you may have no x-intercepts. It all depends on the function. So these two pictures are just characteristics of a quadratic function, of the graph of a quadratic function. When we get into graphing them, you'll see. Okay, and the last part of our quadratic, the graph of our quadratic function, is that you have something called the axis of symmetry. This is your best friend when graphing a quadratic function, because since it's the axis of symmetry, everything across from it is symmetric. So let's say I had a point over here. Well, if I wanted to find another point, all I would have to do is take this point and reflect it across the axis of symmetry. And there you go. You have your points. So as long as you have 3 points, one of those points including the vertex, you can graph your function. And these graphs are called parabolas. Okay. Okay, so that's what we're looking at. The graph of a parabola. These are called parabolas. Okay. Okay, and the other graph is if our leading coefficient is negative, then the graph will open down. So over here, this means that the leading coefficient is negative. And again, same characteristics, vertex, y-intercept, 2 x-intercepts, maybe 1 x-intercept, maybe no x-intercepts, and an x is a symmetry. Okay, those are the characteristics of parabolas. Okay, so here in this box, let me move myself, there we go, minimized. Okay, in this box, you have 2 forms of a quadratic function. One is vertex form, and the other is standard form. Well, we will not be messing with vertex form, so we can ignore all of this if we have to. Okay, so we are only going to be messing with standard form. So we are going to do the ax squared plus bx plus c. So with that being said, in order to find the vertex, the main point of your parabola, we are given a formula, which is right here. To find the h value, we will use h equals negative b over 2a. And to find the k value, you will take the h value that you found, plug it into the original function, and solve for k, or solve for y, whichever that is. Okay, so with that being said, to get k, you take this h value and plug it in for x. That's how you get k. So that would lead you to get k. Okay. All right. So let me just erase those. Those will be on the video. Okay. All right. And now, if you find h and k, you find the main point of your parabola, you find the middle point, the main point, which means that next we want to find our line of symmetry, our axis of symmetry. Well, to find our axis of symmetry, we use this formula, x equals negative b over 2a. Well, if you notice, this is the same formula that you use to find h. Here, h equals negative b over 2a. Here, x equals negative b over 2a, which means that if you have h, this means you have your axis of symmetry. So if you have the value for h, then you have the value for your axis of symmetry. Those go hand in hand. That's 3 points right there. Okay. All right. Again, I'm going to erase that. There we go. Okay. Now, some concepts we know already that we can apply to the quadratic function. How to find a y-intercept. To find a y-intercept, we let x equal 0 and we solve for y. X-intercepts. To solve for x-intercept, we let f of x equal 0. Remember, f of x is the same thing as y. F of x is just pronounced f as a function of x, right? So this function depends on x, which means it's just like y. Y depends on x. Okay. All right. So let's see. Okay. So for an x-intercept, you let y equal 0 and you solve for x. All right. Now, maximums or minimums. Will your quadratic function have a max or min? This all depends on the sign of your leading coefficient. If a is negative, you'll have a maximum. If a is positive, you'll have a minimum. Now let's go back up and see what that means. Let's look at the very first graph. So we see that on the very first graph, our parabola opens up, which means that our leading coefficient is positive, which means that the vertex happens to be the lowest point on the graph, the lowest and smallest y value on the graph. So this means that our vertex is going to be a minimum. That's always. If your parabola opens up, you will always have a minimum. Now, if our parabola opens down, this means that the vertex is the largest, is the highest point on the graph, which means it'll have the largest y value on the graph, which means if your parabola opens down, the vertex becomes a maximum. The vertex becomes a maximum. That's all that means. Okay. Max and mins. Next is range. Remember, range deals with y values. The range is the set of all possible y values. If your graph has a maximum, then the range is all your y values up to that max. If your graph has a minimum, it's your y values from your minimum all the way up to infinity. And I'll show you what that means again. Let's go back up. Okay, again, looking at the first graph for a parabola that opens up. Well, if you notice something, these tails are both headed towards infinity. This means that my range, what we talked about, if my parabola opens up, then the range will start at the smallest y value. Well, it just so happens that the vertex is a minimum, and the vertex will contain the smallest y value. So for my range, we're going to start at bracket k. K represents the y value of the vertex. We start at k, and we shoot up towards infinity. And that's the range for a parabola that opens up, okay? Okay, so it starts at the smallest y value and shoots up towards infinity. That is the range for a parabola that opens up. So remember that k is just a y value, but it is the y value of the vertex. Yeah. Value. There we go. Okay. And then if you have a parabola that opens down, well, if you notice on the parabola that opens down, these tails are headed towards negative infinity. So for range, we always start with the smallest y value, and our smallest y value on a parabola that opens down is going to be negative infinity. So my range here is going to be parentheses negative infinity. We come all the way up to the vertex, which holds the largest y value of the whole graph. We come all the way up, and we stop at k, the y value of the vertex. And again, just to show you, the vertex is always noted as h. K. All right. Those are the characteristics of a parabola. One that opens up, one that opens down. Okay. Okay, here we go. Let's get into graphing these quadratic functions. So there we go. Okay. So many emails. Leave me alone. Okay, sorry. Okay, so find the vertex, intercepts, maximum or minimum, and graph for the following quadratic function. Okay, so example 1, f of x equals negative 2x squared plus 16x minus 24. Okay, so let me bring this down. So what we want to do is label everything like always. Remember that this is in the form of ax squared plus bx plus c. So we're going to label a, b, and c. There's no need for a c, but we're going to do it anyways, just as good habit. Okay. So over here, a is negative 2, b is 16, and c is negative 24. So we label everything nice and neat. Now the very first thing we're going to do is find the vertex. So let's say A. Find vertex. And remember, we're looking for the vertex. So the first thing we should do is find H. And to find H, we use that formula on the very first page. H equals negative b over 2a. Well, guess what? It's a good thing we labeled b, and it's a good thing we labeled a, so now we can plug in for b and a. So let's do that. We get negative 16 over 2 times negative 2. Negative 16 over negative 4 gives me 4. There's our H value. Okay. And now, to find K, take 4 and plug it in for x into the original function. So K is going to equal f of 4, which means you are going to take 4 and plug it in for every single x into the function. So f of 4 equals negative 2 times 4 squared plus 16 times 4 minus 24. And I have a calculator with me. Let me turn my light on. Negative 2 times 4 squared plus 16 times 4 minus 24. We get 8. So we have now found our H value. We have now found our K value. So down below, I'm just going to write that as the vertex. So our vertex is going to be the point 4, 8. That's our vertex. Okay, perfect. So now we found the vertex. Let's go ahead and find some more stuff. So it doesn't say to find it, but let's find the axis of symmetry just to do it. It's one of the easiest things to do. So that's the next step. Axis of symmetry. Well, this one is easy money because if you have your h value, you have your axis of symmetry. Remember, to find your axis of symmetry, it's given by x equals negative b over 2a. Well, that is the same formula we use to find h. So this means if h is 4, the axis of symmetry must also be 4. So this means that our axis of symmetry is the vertical line of x equals 4. There you go. Easy. Now let's go ahead and find intercepts. C. Let's find our x-intercepts. And to find x-intercepts, you let y equals 0. Or in this case, f of x equals 0. Same thing. Okay, so let's do that. So we take the function negative 2x squared plus 16x minus 24. Negative 2x squared plus 16x minus 24. Set it equal to 0. Okay, and now we want to solve this by factoring. So hopefully if it factors. If it doesn't, then I'll show you another method, which is really nice. But let's see if we can factor this. So since this is an equation, I see that I have a greatest common factor of negative 2. I'm just going to divide the whole thing by negative 2. I'm going to say divide by negative 2, divide by negative 2, divide by negative 2. Now, this is probably something new you're seeing. I haven't done this before, but it's going to be the same concept as me factoring out the negative 2 and then dividing by negative 2. So why not just divide everything by negative 2 to get rid of it? Same exact process as if I were to factor it out and then divide it. Okay, with that being said, I get x squared minus 8x plus 12 equal to 0. Okay, which means that this looks definitely factorable. The only factors of 12 that can make negative 8 are 6 and 2. And look at the signs. Minus plus means that this is x minus a number, x minus a number equal to 0. 6 and 2. This means x equals 6 and x equals 2. Okay, but now remember we're finding x-intercepts, so these we have to convert into actual points. This becomes 6, 0, 2, 0. And here are your x-intercepts. Okay. And then D, y-intercepts. And then we can move on to max, min, and graph. Well, graph and then max, min. Okay. All right. D, y-intercept. You let x equal 0. This means that we take 0 and plug it in for x into the original function. So get that original function back. And this is probably the easiest intercept to find. So I'm going to rewrite this as f of 0 equal to negative 2 times 0 squared plus 16 times 0 minus 24. Well, the y-intercept always works out nicely because the first term becomes 0, the second term is 0, and all we're left with is the constant of negative 24. There's our y-intercept. And I'll rewrite it as an actual coordinate. 0, negative 24. There we go. Okay, so we have all the information we need to graph. So let's go ahead and graph it. But let me look at my x and y values, make sure I don't have to make different intervals on my graph. 4 and 8 is my vertex. Axis of symmetry is 4. X-intercepts are 6 and 2. Y-intercept is negative 24. So the only things I probably have to change are my y values, since I have negative 24 down there. So the only y values I see right now are 8 and negative 24. So let's adjust our y values accordingly. I think our x-axis can stay the same. So we can just go by 4s. Let me see, 4, 8, 12, 16, 20. Whoops, don't do that. Sorry. So we'll go by 4s. So here we go. This will be 4, 8, 12, 16, 20, 24. Same thing down here. Negative 4, negative 8, negative 12, negative 16, negative 20, negative 24. And then everything else, I believe my x-axis can stay the same. So first thing we want to do is plot our vertex. So let's do that. So my vertex is at 4, 8. So 1, 2, 3, 4, and 8. There's my vertex. And then next thing I want to plot are my x and y intercepts. So my x-intercepts are at 6 and 2. Come back here. 2, 3, 4, 5, 6. There's my x-intercepts. My y-intercept is at negative 24. Okay, and now I said you only need 3 points to graph your parabola. 1 point being the vertex, which we have, and then the 2 points we have that could have worked were the x-intercepts. We actually had 2 x-intercepts, so we could have graphed this already without caring about what the y-intercept was. But having more points, the more points, the better. So now we can actually connect. Okay. All right. Well, actually, before I do so, let me show you how the axis of symmetry works. So the axis of symmetry cuts straight through your parabola. And we found that the axis of symmetry was the line x equals 4. So that's the line x equals 4. That's your AOS. Axis of symmetry. Okay. So let's say we didn't have the x-intercepts and all we had was the y-intercept. So this means that, well, count how many spaces the y-intercept is from the axis of symmetry. That is 1, 2, 3, 4 spaces. Since the axis of symmetry means that everything reflects across it, this means that to get my other point, I would go 1, 2, 3, 4 spaces. And there would be my other point. That's how the axis of symmetry works. That's why I say the axis of symmetry is your best friend. And now we can connect. So There you go. And the very last question I believe it's asking is, does this have a maximum or minimum? And since our parabola opens down, we are definitely going to have a maximum. This is a maximum. All right. And it's only a max at the y value. So max at y equals 8. Or we could even say k equals 8, because they're the exact same thing, right? Okay. Let's get through some other stuff in case you are asked. Remember, this is a quadratic function. If you are a quadratic function, you are also considered a polynomial. And if you remember that anything about polynomials is that their domain is all real numbers. So this is just in case we're asked. We're not asked on this question, but it's good to know. The domain would be negative infinity to infinity. Actually, let me write it so it's not going off the paper. And our range, since our parabola opens down, those tails are headed towards negative infinity. So negative infinity would be our smallest y value. And then we would stop at, so we go to negative infinity, we come up the parabola, and we stop at the y value of 8. And there we go. That's how you graph your parabola. Okay, cool. Not bad. Let's do it again. Okay, let's do it again. Okay. First off, label everything. A is 1, B is negative 8, C is 5. A is 1, B is negative 8, C is 5. Okay, so step 1, let's find the vertex. Or step A. Vertex. H equals negative B over 2A. So negative 8 over 2 times 1. 8 over 2 is 4. There's my H value. Remember to get your K value. Plug it in to the X. So still going. Let me drag this down. Okay. K is going to be S of 4. So 4 squared minus 8 times 4 plus 5. 4 squared minus 8 times 4 plus 5. I get negative 11. Which means that I have my K value, right? Yep. Okay, so now we have our vertex at 4, -11. Okay. Moving on. Step B. There we go. B, axis of symmetry, easy money. Remember, if you have your H value, you have your axis of symmetry. So axis of symmetry is just X equals 4. Okay. Hey, that was easy. C. Intercepts. X intercepts. Let S of X equal 0. So X squared minus 8X plus 5 equal to 0. Okay. So here we come up to an issue because there are no factors of 5 that can give me -8. Well, the only way to solve our x-intercepts then is to use something that we all love, maybe we all hate, who knows. In order to solve for x-intercepts, we must use the quadratic formula. Which we're not going to do. I'm going to save you some time. This is why I said axis of symmetry is your best friend. So with that being said, I'm going to put here as these x-intercepts are too ugly. And let's move on to the y-intercept. Just save you a bunch of time here. So now D. Y-intercept. Let X equal 0. So I'm going to have S of 0 equal to 0 squared minus 8 times 0 plus 5. That becomes 0. That becomes 0. You're left with 5. So this means my y-intercept is 0, 5. The y-intercepts are the easiest ones to find. Okay. So that's it. Following the same steps above. Last step is y-intercept. Next step is graph. So look at my vertex. 4, -11. Axis of symmetry is 4. We're not going to care about x-intercepts right now. And y-intercept is 0, 5. Okay. So let's do it. 4, -11. We don't go to -11, but we can just go that extra step out, right? Down here. There's -11. Okay. And let's plot our points. Okay. So x-axis stays the same. 1, 2, 3, 4. And right there. There's -11. Oh, that's a big green dot. That's too big. There we go. 1, 2, 3, 4. There we go. That's better. 4, -11. And then next we have our y-intercept of 0, 5. Right? Let me make sure that's correct. 0, 5. So now we're going to come up here and plot 0, 5. 1, 2, 3, 4, 5. There it is. Okay. Now we're wondering, what do we do next? We only have 2 points. I said 3 points make a parabola. This is where the axis of symmetry becomes your best friend. Our axis of symmetry is x equals 4. There you go. So that creates a vertical line at 4. So let's do that. 1, 2, 3, 4. cut straight through it. And see if I can make it a little smaller. Now, let's look at your y-intercept. How many spaces away is your y-intercept from your axis of symmetry? 1, 2, 3, 4. This means you can reflect that point over the axis of symmetry 4 spaces. 1, 2, 3, 4. And there's my third point. 3 points to make the parabola. Connect your points, we're done. And perfect. And yes, somewhere around here are the X-intercepts, but we don't care. They would have been way too ugly to do. But if you want to see how the quadratic formula works on that, I could show that in our class lecture, because I don't want to spend too much time on that. If we can avoid it, let's avoid it. Okay. Again, looking for a max or minimum. This one opens up. So this means that we are going to have a minimum at the k value of -11. Minimum at k value -11. Again, domain is still all reals. Range is now different since my parabola opens up. The range starts at the smallest y value, and our smallest y value happens to be at the minimum. So my range will start at -11 and head up towards infinity. There we go. Beautiful. Nice. Okay, keep going. Another one. Okay. All right. Actually, I'm going to skip this one. I think you have it down. Of course, I'll fill these notes out later when I'm done. Let's move on to the actual application, so I'm not babbling off too much on how to do these. Okay. Let's get to the actual application. Okay, example 4. A company that sells notebook computers has the following revenue and cost functions. Revenue is x times 2,000 minus 60x. Cost is 4,000 plus 500x. X is thousands of computers. So just highlight that important piece of information. And C of X and R of X are in thousands of dollars as well. Okay. So just remember, when stating our answer, we want to put it in terms of thousands. Both functions have the domain. Both of these functions are stuck between 1 and 25. So they're stuck between 1,000 and 25,000 computers. That's their domain, right? So this is the domain. So if we have to graph this, this is telling us what x values to use. It's telling us to use numbers between 1 and 25. Easy enough. Okay, sketch a graph of both functions in the same rectangular coordinate system. All right, cool. So let me see something. I'm gonna write these down. R of x equals x times 2,000 minus 60x. C of x equals 4,000 plus 500x. Okay, so the first thing we're going to do is graph this function. So that's step A, which means we are going to make tables for both functions. And I'm going to show you how to do that in the calculators, right? Okay, so here's A, and the first one I'm going to say x and R of x. And the other one's going to be x, and c of x. So here's the tables we're making. And if you're wondering what x values to choose, just remember to refer to your domain. We're going to use x values from 1 to 25. So it'd probably be best to do everything by 5s. But we're going to start at 1 first. We need that 1. So let me do this. So we're going to say 1, 5, 10, 15, 20, 25. And then 1, 5, 10, 15, 20, 25. And these are all numbers picked from the domain at the top of your paper. Okay, now I'm gonna go to our actual graphing calculators, or our calculators. I'm gonna stop sharing this. I'm gonna share my lovely mug. There we go. And I'm gonna open up the TI-30 and the TI-84. Oh, my dog is barking at everything. He's a dead man. All right, let me put myself somewhere. There we go. Okay, so we are typing these functions in. So the left side is the TI-30, the blue calculator. The right side is the TI-84. Let me just make sure. Yep, we're sharing this. Perfect. Okay, cool. Okay, so what we're gonna do, look at the left side first. This is for the TI-30. We're gonna hit table. We are going to do add edit function, or if you have the blue calculator, maybe it's better showing the blue calculator. Let me see. How do I change calculator? Let me see. TI-30 Pro. No, that's the Pro. How about multi-view? Table, there we go. Table y equals, and I'm gonna type in this function just as I see it. X times 2000 minus 60 x, close parentheses. That's my revenue function. So the first function I'm typing in is my revenue function. And then I'm gonna hit enter, ignore, start, step, go to auto, hit ask, hit enter, go down, hit OK. We get our XY chart, right? And now I'm gonna type in the numbers I need. 1 is 1940. So I'm gonna write all this down while I'm doing it. 1 is 1940. And then 5 is 8,500. And then 10 is 14,000. And then 15, I'll go back up and overwrite. 15, enter, 16,500. And then type in 20, 16,000. And type in 25, 12,500. There we go. Okay, so that's how we do it on the TI-30. Let me see if I did the Pro, right? Let's see, the Pro. If I hit table, you should have add, is it that one? Or the plus? Let me see, table. Either way, yeah. So you do add edit function, enter, f of x equals, do the same, x times 2000 minus 60x, close, enter, leave that blank, enter, go down to x equals question mark, enter, enter, and you get the same thing. So 1, 5, 10, yada, yada, yada. Okay, now, graphing calculator peeps. Look on the right side of the screen. Hit your y equals button in the top corner. Clear out that and type in our function. X times 2000 minus 60x. close, hit enter. Then we're going to hit second window. Table start, don't care. Table, don't care. Independent, we care. Go to ask, hit enter. Perfect. After you do that, hit second and graph. Boom. Beautiful XY chart. 1, 5, 10, 15, 20, 25. Same thing. Okay. And now, those are all the ones for the revenue function. Now let's type in the cost function. Good thing about graphing calculators is you can have as many functions as you want. So let's type in the cost function of 4,000 plus 500x. Enter. Everything should be the same, but just double check it. Second window, we're still on ask. Second graph, you now have a second XY chart with the same values. Look, our work's done already. My goodness. So I'm going to write those down. 4,500, 6,500, 9,000, 11,500, 14,000, and 16,500. Okay, perfect. So graphing calculator, our work is done. TI-30, you still got a little more work to do. Well, if you have the TI-30, I think you can add both functions. Look at this, 4,000 plus 500x, enter, enter, enter. Yep, look at that. But only 3 values at a time. So there's that. If you have the fancy chromed out one. If you don't, TI-30 multi-view, you have to hit table, clear this one out, type in the new function, 4,000 plus 500x, enter, 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 and again, start over. 1, 5, 10, scroll up, overwrite, 15, you get the point from here. So now we have our values. Okay, stop share since I have my X and Y values, and now I'm going back to my laptop. Zoom, share, me, share, OneNote, whoops, there I am. Beautiful. And there's our graph. Okay, so I am going to go down to our graph now, down here, using those values, 1, 5, 10, 15, 20, 25. So that's what we're going to label the bottom x-axis as. So here, let's start the very first intersection at 1. 1, where'd you go? There you go. 1, and can I skip? 5, 10, 15, 20, 25. I sure can. 5, 10, 15, 20, 25. Okay, cool. Oh, they're not showing up on my laptop. That's weird. Okay, there we go. Okay, so we labeled the x-axis. Now let's look at the y values. How can we make this appropriate? 1940, 8,500, 14, 16, 5, 16, and 12. 45, 65, 9,000, 11,500, 14, 16. I say we go by 2000s. Keywords here are sketch. It doesn't have to be perfect. So let's do our y values by 2000. And can I skip? Probably not. 2, 4, 6, 8, 10, 12. Nope. So we're going to make them normal. Okay. So 2, 4, 6, 8, 10, 12, 14, 16, 18. And remember, these numbers are in the thousands. Okay. I mean, same with down below, 1, 5, 10, 15, 25. These are also in the thousands. Okay, well, let's graph. Let's see what we have. Okay, looking at that chart above, I'm gonna make revenue, well, since I wrote in black, revenue is gonna be black. Okay. So 1 in 1940, that's gonna be somewhere around there. Whoops, I always do that. Nope, not there. 1 in 1940, I'm gonna say somewhere right there. 5 in 8500, somewhere around there. 10 and 14,000, right on the money there. 15 and 16,500, somewhere around there, maybe a little higher. 20 and 16,000, right on the money. And then 25 and 12,500, somewhere around there. So here is what our revenue looks like. This is R of X. Okay, hang on. All right, and back. Cool. All right, so graph revenue. Now we graph cost function. 1 and 4,500. Somewhere around there. Let me make that dot a little bigger. Somewhere around there. And then 5 and 6,500. Somewhere around there. 10 and 9,000. Right there. 15 and 11,500. Around there. 20 and 14,000. Nope, that's not 20. The next one over. There's that. And then 25 and 16,500. Up there. And connect. There we go. And that is cost function. Okay, excellent. So graph that. Now we just did A. B wants to find the break-even points. We want to know where are the points that the revenue and cost function intersected at. So that's what we want to find. So if I change this color, we want to know what is this point where they intersect at, and what is this point where they intersect at. These are called your break-even points. Break-even point. That's what we're going to look for on the next step. And hold on to your butts because it's going to be a long one. It does involve the quadratic formula, unfortunately. Okay. So B, let me see. Yep. Okay. All right. B, to find break-even points, it's where revenue equals cost. This means that I'm going to take the revenue function of x times 2,000 minus 60x and set it equal to my cost function of 4,000 plus 500x. What I'm going to do now is distribute the x on the left side and then move everything over to one side to solve for x. So let's do it. This becomes 2,000x minus 60x squared equal to 4,000 plus 500x. All right. You like your x squares to be positive, so why not move everything over to the right side? So I'm going to say minus 2,000x minus 2,000x plus 60x squared plus 60x squared. So over here, cancel, cancel, cancel. You're left with 0 on the left side, equal to 60x squared minus 1,500x plus 4,000. All I did was rearrange everything on the right side. Highest power to lowest power to constant. That's what happened on the right side. Okay, so now, well, we don't want to factor this, so we apply the quadratic formula to all of this, which means label A, B, and C, which I'll do in another color. A is 60, B is negative 1,500, C is 4,000. Okay, now plug these into the quadratic formula, and you'll get x equals negative times negative 1,500 plus or minus the square root of negative 1,500 squared minus 4 times 60 times 4,000 all over 2 times 60. Woo! Okay. So still going, clean it up a bit. X equals positive 1,500 plus or minus, and I'm gonna go to my calculator. So stop sharing this screen. Share my screen of my calculators. And second, quit. All right, I'm typing in the square root part, just the square root part. Second, square root, parentheses, negative 1,500 squared minus 4 times 60 times 4,000. Enter. There we go. 1135.78. So in the sake of all this, I'm just going to round it up to 1136. 1136. Same for you guys on the graphing calculator. It's the same exact input. Second square root, parentheses, negative 1,500 squared minus 4 times 60 times 4,000. There we go. Same thing. Okay, now back to my screen. All the switching back and forth. Zoom, zoom, zoom. Share my screen. Do it, do it, do it. There we go. Okay, so now we're back. 1500 plus or minus 1136 over 120. So we're going to do the plus route and we're going to do the minus route. So let's get started with that. First on the plus route, x equals 1500 plus 1136 over 120. I'm going to type that in my calculator on my desk. 1136 over 120, and I get 21.96. So I'm just going to round that to 22. And then the minus route, x equals 1500 minus 1136 over 120. I get 3.03, which we'll put as 3. Okay. Whew. Step B is not done yet, because guess what? The only thing we have found are the x values. We're looking for a break-even point. And when I say point, I mean an x and a y value. So that's what we're looking for. So maybe I can put that up here. A break-even point looks like x and y. And all we have found is just the x value. Well, we're almost there. I got good news for you. Since we have the x values, take these x values and plug them in to either the revenue function or the cost function. And the reason you can plug it into either function is because since these are break-even points, well, this means that no matter what function you plug into, you'll get the same answer, because if they break even, your functions are equal. So plug it in the revenue, plug it in the cost, you're gonna get the same thing. Well, since we cut some decimals out, it'll be a little different, but you get the gist of it. So plug it into whichever one looks easier, and for me, the cost function looks a lot easier to plug into. So let's do that. All right, so still on this step, I'm gonna say, since we have the x values, let's go ahead and find the y values. Change color, there we go. All right, all right. Come on. At x equals 22, c of 22 equals 4,000 plus 500 times 22. And then the same here. At x equals 3, c of 3 equals 4,000 plus 500 times 3. Let's see what we get. Okay, 4,000 plus 500 times 22, 15,000. $4,000 plus 500 times 3, 5,500. And guess what you just found? The y values. So put that up here. Okay. So these are all considered your y values. Your y values of the break-even points. So after much, and just after a lot of work, it's just a lot of work, I know, but we can get through it. So after all of this, our break-even points, our BEPs, are 22 and 15,000 and 3 and 5,500. So that's what these points would be over here on your screen. This point, this BEP would be, change color back. That one would be 3 and 5,500. This one would be 22 and 15,000. There we go. That was the hard part. That's what we had to get through. So you see what we have to go through. Okay. And the last question, for what values of X will a loss occur and a profit? So C. Let's reference our graph. So what's another good color? Let's just do this blue. Okay. So a loss occurs. A loss happens when revenue is less than cost. And we only state X values here. So looking at our graph, the curved line, the black line is revenue, the green line is cost. So looking at our graph, it looks like that from the X value of 1 to the break-even point X value of 3, we have a loss because revenue is below cost. So I would say that our first loss would be from 1 to 3. And then look at the end of the graph. Starting at the break-even point of 22, you see that the cost function is above the revenue function. So the cost function is above the revenue function, which means that's another loss. So from the break-even point of 22 to the final number of 25 is when we will have a loss. Okay, so there's that. There's loss. And now we look at profit. Profit happens when revenue is greater than cost. Well, look at the start of our first break-even point. Right here at 3, it looks like the revenue function is greater than our cost function until this break-even point. So this means that our profit is going to be from the break-even X value of 3 to the break-even X value of 22. (3 to 22). There's profit. That's perfect. Okay, awesome. If you wanted to write these as double inequalities to represent 1 and 3, you would say 1 is less than X, which is less than 3, and then 22 less than X, less than 25, and down here, 3 less than X, less than 22. There we go. And that problem is done. Oh boy, that was a lot. Gee golly, mister, that was a lot. I need coffee all day. Okay, cool. Next, and the very last one. Okay. A sporting goods store finds that it sells X golf clubs per month. Its cost will be 182x plus 4,200. Revenue will be negative 2x squared plus 400x, both in dollars. Find the profit function, find the break-even points, find the number of golf clubs sold to reach max profit, find maximum profit, graph it, find intervals of profit and loss. Ooh, here we go. Okay. So first thing we want to do is find profit. So profit is given by revenue minus cost. Well, you see there, they already gave us a revenue function. They already gave us a cost function. All we have to do is plug them into this profit formula. So let's do that. That is A. P of X equals, now my revenue function, that's what I'm plugging in. And remember, when we plug in, always include parentheses. Negative 2x squared plus 400x close minus parentheses. Now plug in your cost function. 182x plus 4,200. There we go. This is revenue minus cost. Okay, now simplify. P of X equals negative 2x squared plus 400x. Take this negative and distribute. Negative 182x minus 4,200. Okay, clean it up. P of X equals negative 2x squared. 400 minus 182 is 218x minus 4,200. This is our profit function. B is done. Okay. B, find the store's break-even points. Okay, so let's do that. Break-evens. Back to that. B. So remember, if you break even, revenue equals cost. Well, what if I told you that we already have this function? It's the profit function, and I'll show you. If I said minus C of X, you would get R of X minus C of X equal to 0. Well, what is represented by R of X minus C of X? That happens to be P of X. And that's what we have already. So we already have that function. So we can definitely go ahead and skip the step of plugging in revenue, plugging in cost, mixing terms around. It's already done for us. Profit has that for us already. So all we have to do now is take profit and set it equal to 0. So I'm just going to make note of that. Okay. So this means that to find break-even points, set profit equal to 0. Okay, so take our profit function, negative 2x squared plus 218x minus 4200. Set it equal to 0. And again, unfortunately, we've come back to this. We don't want to factor this. And since we don't and really can't factor it, we introduce the quadratic formula. So again, label everything. A is negative 2. B is 218. C is negative 4200. Plug these into the quadratic formula. X equals negative 218 plus or minus the square root of 218 squared minus 4 times negative 2 times negative 4200. All over 2 times negative 2. Clean up. X equals negative 218 plus or minus, and I hope you know how to type it in your calculator by now. So I get 218 squared minus 4 times negative 2 times negative 4200, and I get 118 over negative 4. Okay, now plus route, minus route. X equals negative 218 plus 118 over negative 4. Negative 218 plus 118 over negative 4, I get 25. X equals negative 218 minus 118 over negative 4. Negative 218 minus 118 over negative 4. 84. And remember, these are just X values. You still need to find the Y values. Okay. So I'll do that over here. Let me draw a little arrow. Find Y values. Or do I have space over here? Yeah, I got a little space over here. Okay. So at X equals 25 and at X equals 84, again, plug them into an equation of your choice, revenue or cost. It looks like cost is always the easiest one to plug into, but it doesn't matter which one you plug it into, you're still gonna get the same answer. But cost is just always easy to plug into. So 182x plus 4200. So C of 25 gives me 182 times 25 plus 4200, and C of 84, 182 times 84 plus 4200. Let's see what we get. 182 times 25 plus 4200, 8750. Yeah, I ran out of space, sorry. So this y value and then 182 times 84 plus 4,200, 19,488. All right, that was 182 plus 4,200. Okay, good. Okay, so this means that finally we have found our break-even points. My goodness. So our break-even points are going to be 25 and 87.50, and then 84 and 19,488. Perfect. These are our break-even points. Again, it is a process. It's a struggle, but hey, it's just algebra. You got to get through it. So all of that was B. Oh, God. Okay. C and D we're going to do together. Find the number of golf clubs sold to reach the maximum profit and find the maximum profit. If you ever see these questions together, guess what they are looking for? We learned it at the very beginning of this page. If you ever see these two questions together, all this means is find the vertex. Find vertex. That's what it means. So find the number of golf clubs. Well, remember, golf club is represented by X in this problem. Find the maximum profit. That is the Y value of this problem. So that's all we're looking for. We're looking for H and we're looking for K. So C is going to be the value of H and D is going to be the value of K. So that's all we're looking for, H and K. Okay. So there's my, and we're going to use our profit function for this because it says find the number of golf clubs sold to reach maximum profit. So we're going to use the profit function I have above. So here is step C. C. Oh, and D. Find vertex. Keeps it simple. Okay. And lucky for us, we already labeled A, B, and C of the profit function. So we're ready to go. Okay. So find vertex. H equals negative B over 2A. That gives me negative 218 over 2 times negative 2. Negative 218 over negative 4. 54.5. Since we can't sell half a golf club, let's go ahead and round up. We'll make it 55. And voila, you just answered C. 55 happens to be the max number of golf clubs we can sell to make max profit. So 55 is the number of golf clubs. And now, to find K, to find K, we take 55 and plug it into the profit function. P of 55. So, where's my profit function? Right There, I can use that one. Okay. -2 times 55 squared plus 218 times 55 minus 4,200. -2 times 55 squared plus 218 times 55 minus 4,200 gives me 1,740. All right, so what all of this means is that if we sell 55 golf clubs, we make a max profit of 1,740. Now that doesn't seem like a lot of profit to bring home, but hey, profit is profit. Because this is after you've paid your employees everything. You paid your cost, you paid your employees, you paid your shipping, you paid everything. This is what you take home, 1,740. So that's all C and D wanted. Find your max profit. Okay. Now it says graph the profit function. Okay, well, if we're graphing profit, we already have points for us. All we're doing is graphing profit, nothing else. We will use the break-even points of 25 and 84, and we will use the vertex 55 and 1740 to graph this profit function. So let me write that down. Okay, look at our X values, 25, 84, 55. Let's go by 20s? Sure, let's go by 20s. Why not? And this was always gonna start, let me see. I don't think we were given a domain, were we? No. So yeah, so we could sell 0 golf clubs if we wanted. Or we can start at 1. Let's just start at 1 because we don't make anything if we sell 0 golf clubs. So this is going to be 1, and then we can make the jump to, I think, maybe we can even go by 10s. Let me see. 10, 20, 30, 40, 50, 60, no, 20, 20, 40, 60, 80, 100, right? 30, 40, 50, 60, 70, 80, 91. Yeah, we can go by 10s. You just can't skip. Okay. So 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. That's where we'll stop. Now, let's look at my Y values. 1740, 8750, 19488. I say let's go by 2000s again. No skipping. 2, 4, 6, 8, 10, 12. 14, 16, 18, 20. Okay, cool. Right there, you see the only 3 points I need. Break-even points, vertex. Now let's graph. Okay. Okay. 25 and 8,750 is my first point. So 25 and 8,750, somewhere around there, right? Okay. And then let's see. 84 and 19,488. I might be doing this wrong. I probably am. Yeah, I don't think I should have done that. Those are the break-even points, but we're only graphing profit. So bear with me a second. And then 55 and 1740. Yeah, none of this would make sense because this is what it would look like, and none of our profit should look like that. My bad, my bad, my bad, my bad, my bad. Okay. Ugh, sorry, guys. All right. So to make more sense of this, these break-even points we would use if we were graphing revenue and cost. So this is my mistake. Just like in the last problem, we would use these break-even points to graph revenue and cost. This problem only wants to graph the profit function. So with that being said, let's look back at this. So the only true point we have right now is the vertex. This vertex is from the profit function. So this means that let's first look at the setup for the profit function. When we use the quadratic formula to find break-even points, we got x values of 25 and 84. Okay, so these are the x values of the profit function, which means that if I were to take these x values and plug them into the profit function, they would give me an answer of 0. So we're not too far off, which means that the only 3 points I'm going to use now, I'm going to come down here, because now 25 and 84 actually become x-intercepts. So what I'm going to write down here is that we have x-intercepts at 25 and 0, 84 and 0. And again, the reason these are x-intercepts is because we set the profit function equal to 0. And that is the process you use to find x-intercepts. And since y equals 0, we got 25 and 84, which become x-intercepts for the profit function. Now, what you see over here on the right side is how to find break-even points. This means we take the x values and plug them into the revenue or cost function. So this is where the revenue and cost function intersect. Now, here's where the confusion started, because it said graph profit. It didn't say graph revenue and cost function. So we would only use these points to graph revenue and cost, not profit. Okay? So hopefully that clears up some confusion. So these are for revenue and cost only. For revenue and cost, not profit. Okay, sorry guys. So that means, again, coming back to step E, graphing it, the x values actually magically are fine. The y values I do not need. So let me erase these. Because now, based on the 3 points you see on the left, the only y value I have here is 1740. So that means I can just go by, you can just say we can go by 500. Why not? And I can even skip. 500, 1,000, 1,500, 2,000. And now let's graph. Okay. My bad, guys. Okay, so now we graph, and I get 25 and 0, which is right here, 84 and 0, somewhere around there, 55 and 1740, I'm gonna say is probably right here. There's our 3 points, and here's gonna be the graph of our profit function. There you go. This is P of X. Ugh, okay, that was my bad. Okay. Now, let me see. We graphed it on what intervals of sales there are profit, what intervals is there a loss. So looking at our graph, well, we know that between, so for a loss, we know we're gonna have a loss between 1 golf club and 25 golf clubs. And then we're gonna have another loss from 84 golf clubs to, we didn't really get a domain this time. So we can put infinity, but we can't really sell infinity golf clubs. So I'm just gonna stop this at 100. That's our loss. Or 1 to 25 and 84 to 100. And then for profit, we're going to have a profit from break-even point to break-even point, or from X-intercept to X-intercept. So our profit is going to be from 25 to 84, or 25 less than X less than 84. And there it is. There are no's for quadratic functions. Thanks, guys.